you very much, Takashi. It's a real pleasure to be here. I am going to talk to you about a complex system, an artificial life system, very much in the spirit of Alex's perspective on what an artificial life system is in the modern world. I think an example of what she was talking about is the Twitterverse. And I've have given you a picture of it there. This picture is made up of a universe of agents that are communicating with each other. The agents are points and the communications are lines. And this is, in a very real sense, an existing artificial life system that is a synthesis of living elements, already living elements, namely people who are actually sending out messages on Twitter, and an artificial infrastructure that Twitter has provided to enable this messaging system. In this talk, I'm going to go through an exercise to kind of illustrate how a complex systems scientist tries to understand a complex system like this, and by making simple models that try and extract certain essential features. And then I'm going to exercise that simple model and to discover something that I think is rather alarming. And then finally, I'll talk about what we might be able to do to deal with it. So here's my toy model. I'm going to abstract that complex space of agents down into a single line of agents on the x-axis of this picture. And each agent in the real Twitterverse has many opinions that they're broadcasting with their tweets. But in this simple model, each agent only has one opinion about one issue. And I'm parameterizing that opinion by a single real number going from left to right. This could be a political opinion. But right now it's rather abstract to ascribe to it something like politics. At any rate, now I'm going to tell you about how these agents with their opinions that they're broadcasting, how they actually change and evolve according to what they're hearing from other agents. So I'd like you to focus on a particular agent, like that's one that's pointed to by this arrow, and you can imagine that that agent is yourself. And so what are you going to do in this Twitterverse world? In this particular model, what I'm presuming you're going to do is that you're going to follow people, you're going to follow other agents that are nearby your own opinions. And then from time to time, you're going to shift your opinion. How are you going to shift it? Well, you're going to listen to all those opinions that you're following, and you're going to move towards the mean of that distribution. Well, you can see from the picture that that means that you're going to move towards in the direction that there's more agents having that opinion, and that means you're going to follow the gradient of this probability distribution. I've written the equations for that dynamic of your opinion on the left-hand side there at the bottom, and it turns out that the equations for individual agents then induce a map on the space of distributions. So you can figure out, well, how do distributions over the whole space evolve? Well, that's something that I've implemented in my computer, and now I can introduce new elements into the model. In particular, I'm going to introduce what I'm calling bots. And these bots are robot agents. They're not human, and their opinions are fixed. And what I want to do is show you what happens when the distribution evolves according to this opinion evolution rule? Well, the basic story is that the bots actually suck in agents to follow their opinion, and the area around the bots ends up increasing, and you end up with polarization. Now, at this point, you might ask, well, is this really valid model? Well, I'm not trying to convince you that it's the only thing going on in the Twitterverse, but I am trying to convince you that it's an important and possibly significant piece of what's going on. To really test it, the hypothesis, we would have to go and analyze data. That's an empirical problem that we're not going to deal with right now. But I'm asking you to bear with me and assume that something like this might be going on. If it is, we have a version of what in artificial life is known as the emergence problem. And this problem basically is a problem that besets many complex evolving systems where you have new innovations coming as a result of the evolution of the system. And the problem is that if you want to study the system scientifically, you might be focusing on a part of the system, and the innovations are happening in another part. And so you miss them. That's the essence of the emergence problem. And I've illustrated how this might happen on the right in our simple Twitterverse model. We have an observer there with the two eyes observing the hump, the central hump of the system, and over on the wings of the distribution, we may have bots causing a peak that is not observed by the observer because the observer isn't looking over there. Well, this problem is a central problem in artificial life, and in the coming conference, there are several talks that are focused on this problem. And this example of the introduction of bots may actually provide an example of the problem. In point of fact, in 2016, in the US elections, bots were used in social media. The effects of the bots were not fully realized at the time, but in retrospect, it's quite clear that the bots actually did suck in people towards their opinions. And so my claim is that that occurrence of the bots is an example of the emergence problem. There are similar issues with other social media, Facebook, for example, but for the moment, let's just concentrate on the bots in the Twitterverse. So initially, social media was very reluctant to react to this problem because they typically had the attitude that, well, the Twitterverse is a free place. Anybody can go and create accounts and tweet whatever they want, and it's a free world. And they essentially ascribed, when I say they, who I really mean is Jack Dorsey, who's the CEO of Twitter. He basically ascribed the same kinds of rights to bot accounts as he did to real people accounts. And since then, they've gotten criticized for that, in large part by public reaction, but also the US Congress has hauled them to hearings, and they now actually acknowledge that bot accounts can actually be dangerous for people, and they're trying to take active measures to close them down. I've included a graph here that comes from Twitter's blog pages about this problem, and it's a fairly recent post. And the news recently, just a few weeks ago, was that up to 10 million accounts per week are being closed down by Twitter because they have been evaluated to be spam accounts or bot accounts. This is a big deal for Twitter because its stock price actually has a strong correlation with the number of users that it has. And so when they're closing down tens of millions of accounts, their stock price can actually go down as a result. But maybe it shouldn't, because they're actually improving the environment rather than making it worse. And so I would say that this is good, but it's actually way too late. It doesn't help us at all for the 2016 elections. So what could we do? How can we deal with this kind of a problem in real time? We should be thinking about this right now in the United States because we have an election this year. So what are we doing about it now? Well, artificial life research has started to give an answer to this question of what can be done in situations like this. Our current proposal is to take a pragmatic approach, and instead of observing a system with a static lens, we propose that when you're observing an evolving system, you actually take your observational instruments and evolve the observations. And if you do this, you can tune this evolution of the observations to try and pick up significant new features in this distribution. In our case, distribution of opinions. It's not an easy process, especially when for the vast quantities of data that are produced by the Twitterverse. But it is possible, and I think it's one pragmatic way to really handle the situation. So what I'd like to propose is that ALIFE researchers and artificial intelligence researchers actually think about how to address this problem in real-world terms. Just recently, and this is just a few days ago, the Department of Justice in the United States released a report on its cyber digital task force that kind of is a laundry list of all the things that it thinks is going wrong in the cybersphere. And they do, in fact, mention bots, but they don't really mention this amplification process that can occur in these complex systems. And the amplification process is the thing that I'm really focusing on as something that can be toxic and produce toxic effects in our social environment. So we really need to figure out how to provide an ongoing analysis of our environment in ways that spot toxicity when it occurs as soon as possible, and then provide ways to actually damp it down. I think this is something that the government has to get involved in. Obviously, the Department of Justice is worrying about this, but it's up to we scientists to actually make connection with policymakers to create a connection to implement the tools that I'm suggesting might actually benefit. Thank you very much.